Testing. Testing. Testing 1 2. 1 2 testing. Testing, testing. Testing, testing, testing 1 2. Testing, testing, testing. Testing, testing, testing 1 2. Testing, testing, testing. Hello, hello. Testing. Testing, testing, testing 1 2. So, if I change this, no one can see my screen. Testing. One, two. Testing, 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 1 2. Testing, testing, testing. My audio seems to sound like crap. Testing. Testing again and again and again. Testing the sound. Testing the sound.
Oh, that's way better.
Okay. So I'm going to start in about 15 minutes. Testing, testing. So, I am spreading the word about the stream, which is going to start in about 13 minutes. So, okay. Testing, 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 1, 2. Okay. Wow, there's some people in the YouTube chat. Hello. So, this is my first experimental live stream, and I'd welcome everyone to actually like talk with me and be a part of the stream if you'd like. can ask me questions or whatever. So I'm posting this link. So you'll end up if you join. End up on YouTube if you join. So, just trying to get the hang of this thing. You found my videos helpful. That's great. Great. All right, all right. You start in about 7 minutes. All right, all right. So, just sit tight for 5 minutes. Testing. Okay. Hi everyone. This is an exciting experimental live stream. Hopefully the first of many. Uh, oh, there goes my sound on the other machine. Hang on. Yeah, a lot of this is new to me, so forgive me if the setup is not ideal. So what I'm going to do here is hopefully visualize this data. I'm going to go for about 90 minutes, see how far we get. This is totally unrehearsed, so it may be rough, I'm not sure. But this started when Ian Johnson posted this thing only 2 days ago, where it's a set of scripts that pulls the Git history for all of the D3 Git repositories. So just for some context, in GitHub, D3 is an organization, and there's the main D3 package, which just pulls in all these other packages as dependencies. See, in the package.json for D3, the dependencies just include all of the sort of sub-packages or, D3 packages. So in a sense, this D3 package is just an aggregation of these other smaller packages. And so in here, you can actually see GitHub has this feature of a summary, past year of activity. So this is the kind of data that I want to visualize. Number of commits per repository, or maybe per contributor to visualize the contributions over time. That's what I'm thinking. So this script that Ian Johnson made 2 days ago, it just reads the package.json of the D3 repository and clones all of those repositories, and then this script here runs git log and then formats the output to be a machine-readable, parsable file that has essentially 1 row per commit. And that commit, each one has a hash, a date, an author, a subject, and a body. And I looked through the data, and the file was quite large. So this is my fork of that gist, which is just the data preprocessing part. And what I did was just included the date and the author, because that's really all I think we're interested in. The date and the author, and then when they get combined, the data for all the repositories ends up getting combined, and when it does, you have a repo field as well. So here's what the data looks like. I put it in this GitHub gist so that we can pull from it and use it. So we've got a date, an author, and a repo. And we've got a bunch of these. So here's what I was thinking of doing with this. Let me just find the thing. Here it is. The stream graph. So this is a stream graph visualization that I made a couple of years ago about Trump topics in the news from Google News dataset. And this goes back to 2017, and you can see interest in various topics over time. So this is aggregated, I think, by day, it looks like. So I was thinking of visualizing this D3 Git repository history data using this technique. So instead of different news stories, it would be maybe different D3 repositories that get contributed to over time, or different contributors to the GitHub repositories. So the question is, how do we get from here this data to there, this visualization? So that's what I'm going to be trying to do today. So let's get started creating something. I'm going to use VizHub for this. I'm going to say create a viz. I would like to try the new package JSON template. By the way, this is a new feature of VizHub where you can specify dependencies in package.json, and it hides bundle.js, and you can have a simpler index.html. It actually pulls it in from a CDN, like all the other old Vizes do, but the whole format is much cleaner. And you can use it to pull in any libraries that you want to, and use ES6 import syntax with it. So I'm going to fork this one. I'm going to rename it to WIP work in progress D3 get history viz fork. Okay, so the first thing I'll do is just clear out the README. I was thinking of doing that automatically in VizHub, but because a lot of people never change it. But anyway, I'll clear out that, and I'll say this is an experiment in visualizing, and then I can link to this data. This is an experiment in visualizing D3 get history. So I opened up this Google Meet and shared the link out. So if you want to join this meeting and talk to me and be a part of this stream, you're welcome to. I'll share it out right here. Otherwise, it'll just be me, all alone. Okay, so to get started here, the first order of business is to load in the data. Or actually, probably I should just clear out this whole boilerplate as well. We don't really need anything. And then what I'd like to do next is load in the data. So I'm going to give myself some space to just focus on the code here. And let's load the data. So to do that, we need to import the thing from D3 that we're going to use to load the data, which is either d3.csv or d3.json. Since it's a JSON file, we can import JSON from D3. And then I like to make a variable for the URL of the data so that it's not one huge line. So here's the gist. Here's the data file. So if I click on raw, I'll get this URL. That is the raw URL. And then over in our code, we can say data URL or data URL equals. I'll just paste that there. It's a pretty long line, which I don't really like, but you know, it's whatever. And then we can load it in. We can invoke the JSON function, passing in that data URL, and that returns a promise. So we can say .then some callback that gets invoked with the data. And then in here, I'll just say console.log data just to see what we've got. And then in the console, we could see that it worked. Wow, almost 7,000 commits on D3. That's pretty cool. Okay, we've got date, we've got author, and we've got repo. All right, step one complete. we've loaded the data. In order to get from this data into a format that we can use with a stream graph, we need to aggregate to get, for example, the width of these streams for different dates. And so the data we have to begin with is individual commit events that happen at a point in time. You know, this is the day, this is the time of day. This looks like the time zone. Interesting. Yeah, Mike Bostock is on the West Coast, and Felipe Riviera, I hope I'm pronouncing that correctly, is, I believe, in France. So I think that is the time zone. But at any rate, what I think we should do is aggregate it by some time interval, like week or month, perhaps. It goes over quite a time range. Let's see, what's the oldest commit? 2016. Yeah, so I think months might be a good aggregation. I mean, we can always change it. We can always decide later to change it. But the first step for aggregating would be to parse the dates. Yeah, and then we can use D3 time to figure out, you know, which month it's in, for example. If we're going to aggregate by day or week or month, we don't really need the time of day, and the time zone doesn't really matter. I mean, it might be like rounded to the day before or the day after, but that's okay. We're doing a sort of a coarse-grained analysis. And you know, now that I think of it, we could just chop this string to aggregate by month. That might be the dead simple easiest thing to do. You know? So I think I'll try that. So we can break this down into a very small subproblem, which is, given this string, how do we just get the year and the month? Well, we can use .sub str or substring. You know, I can never remember which is like the canonical one. I think they both work. Let me just research that real quick. For MDN substring. Okay, this one seems legit. What about substr? Substr is a substring of substring, so that's sort of funny. Okay, this one has a thumbs down next to it. It's deprecated. Okay, that's really good to know. So we should use the long form substring. And the way it works is you give it the start index and the end index. So the index start would be 0 and the index end would be, well, I don't know, some character. So substring from index 0 to index, let's say 5, gives us the first 5 characters. But we want to get the month, so I think that would be 7. Yeah, see? That's what we need. So we can just take the substring of 07 of the date, and then we'll get this simplified date string that just gives us the day. Or no, the month, rather, the month. So let's do that. I'm thinking we just iterate over the data and add another field to it, perhaps. So we can say data.forEach d, that's just a convention to refer to a single row, d dot something. What was it again? What was that field name? Date. So d dot date. We can actually just overwrite that one. d dot date dot substring, like that. and then we get just the month. Okay, sweet. So this code is a little cryptic to come upon, so I'll just say aggregate by month. And you know what? We ideally, I think, should be working with JavaScript dates. So while we're at this point, let's just parse the date. I'm just imagining there's a function called parseDate, and we can pass in that string. And to get that function, we can use D3 time format, I believe, which has the time parsing as well. There it is, time parse. So what we can do is import that. This comment is misplaced. I'll put it over here. Import time parse from D3, and then we can say, we can define this variable parseDate equals time parse of the specifier that we need. And so Zane Armstrong has this amazing time format example on blocks.org, which I find more useful than the documentation, just because it has a bunch of concrete examples. And this is exactly the format we want, month and year. So this is the one that we can use. So we pass that specifier right here. And now if we console.log this data after we do all that stuff, we should be able to see those dates. Ooh, parseDate is not defined. Ooh, it's a typo. parseDate. Okay, now it should work. Okay, it worked. We get this JavaScript date object. Okay, sweet. So the next step of this would be to aggregate by month. So this is actually not aggregating, but by month, this is more like parsing date by month. And then to actually aggregate by month, we can use some new machinery in D3 array. It used to be D3 nest, but nest is deprecated and replaced by some cool stuff in D3 array. I believe it's called group. Yeah, see that? D3.group. D3.group is a transformation. It's one of these methods for transforming arrays and generating new arrays. So what D3 group does, let's see, it groups the specified iterable, and an array, by the way, is an iterable, so we can pass in our array into an intern map. And this is a very new thing. It's essentially a map, but it allows dates and other non-primitive keys by bypassing the same value 0 algorithm. Okay, we're getting into the weeds here, but it essentially returns a map. Here's an example. If we have this data, we can group them by name by saying d3.group, passing in data, and passing in a function that we want to group by. And this returns a map. This actually should be intern map, but whatever. And the thing is, you can pass multiple keys. So if you want to group by name and by date, this is how you could do it. And it gives you a map of maps. where the keys, the names, resolve to maps of dates, and those dates resolve to arrays that are sort of isolated from the original data. So if our aim is to create something like this, we do actually need to group by two things. One of the things we'll group by is by the month. And then the other thing we'll group by, I think I want to try two different things. One of them will be by the repository, and then the other one will be by the author. And those will give us totally different visualizations that will say different things. But by the end of this, that's what I want to see, is two visualizations with those groupings. Now we need to take this idea and apply it in our code. We want to aggregate by month. We can take that code there. Instead of using d3.group, I'm going to import group from d3 along with this other stuff. And then we could, I suppose we could reassign data, although that would be kind of confusing. So I'll make a new variable called grouped data equals group data, and then these are just copied from the example. So I should actually figure out what the fields that we have are and use those. One of those is definitely going to be date because we're assigning it right there. So I think this one is okay. And then the other one would be, let's start by grouping by the repository. If we take a look at our data, we can see the repository field is called repo. So that's what we need to group by over here. And the question arises, which should go first? I mean, should we group by, should we group by repo first or by date first? And I think that depends on some downstream code, namely the D3 stack API. But anyway, let's see if this grouping worked so far. Okay, it's a map of 30 things. All right, see that? We've got these various D3 repositories, and for each one, we've got another map inside of it that's just for each month where there is data. Notice that this is a map where the key is the date and the value is the array of original commits that happened inside of that date, that month, and inside of that particular repository. Okay, now we can come at this from the other angle of how to actually code the visualization as a stacked area chart that we can then add labels to make a stream graph. For that, let me take a look at D3 shape, because I know this is where the stacked area stuff is. D3 shape lets you create symbols, arcs, lines, and areas. Yeah, this is the kind of thing that I want. My question is now, what does the input format need to be for area? So here's the constructor. It takes x, y0, and y1. And then if you say area of data, it generates an area for the given array of data. I don't know, it's kind of hard to go from this direction and figure out how to use it. Maybe looking at an example would be better. Okay, here's a stacked area chart example in Observable, and it's ISC licensed. Let's take a look at how this works. We've got the data, which is just a flat array where each object has a date and then a bunch of different keys for the various things that get stacked. So in our case, these keys, I guess, would be D3 repositories. Okay, this answers a good question, which is what format does the data need to be in to begin with to work with this area generator API? Just taking a look at the stream here. I see Robert is here. Hello there. So good to see you. You're welcome to join the meeting if you'd like to collaborate. And actually, let me drop the link to the viz as well, if anybody wants to follow along and or fork or whatever. Anyway, I'll just keep going. So to make the stream graph, we need to get from this, a map of maps, into this, a flat array of objects where each object corresponds to a combination of month and D3 repository. Or no, actually, sorry, that's not what it is. We need to convert it to a flat array of objects where each object corresponds to a month. And that object has keys for each of the various D3 repositories. Okay, so this means to me that we should aggregate at the top level by month. And then we can iterate over those to come up with these objects. So back in our code here, see, we're first aggregating by the repository and then by month. But I think what we want to do is reverse these. So if I just reverse the order to aggregate by date and secondarily by repo, and I'll update this comment, aggregate by month and repository. Then we get a map where the keys are dates. Okay, this looks good. And then the inner maps have keys for each repository and then an array. And so what we're going to want to do is for each one of these outer entries, create an object that has a repo field, and then we use the length of this array. We're going to want to count how many commits for this particular combination. Okay, so I think we're well positioned to take a crack at this. I'm going to make a new variable for this data. I don't know what to call it exactly. Area data, perhaps, or transformed data. I don't know, transformed data. And I think the easiest thing to do would be to create an empty array. I see somebody join the meeting. Hello. Hello there. Welcome. This is my wife, everybody.
Hello.
Cool. So feel free to chime in as I go.
There is a lag in video, it looks like.
Oh, is it? Yeah, if you are looking at the stream, there will be a lag. So just look at maybe close the stream and just look at the meeting, because I'm sharing my screen in the meeting too, this Google Meet thing. FizzHub is super slick. Thank you, thank you. All right, let's try this. Would you mind just muting yourself? Because there's some audio bleeding. Okay, great, thank you. So here's what I'm thinking. We just create this array, and then we iterate through our grouped data, and as we go, we push things onto this array. We could do it another way with like reduce or something, but I think this one would be the most straightforward to code. So what we need to do is iterate over the keys of this grouped data, which is a map. So I have to just figure out how to do that. ES6 map, iterate the keys. If I remember correctly, there was just a keys function. Oh, there's a for each function. Look at that. Executes the provided function once per each key value pair. I don't know if that's what we want, because we really just want to iterate over the keys. Looks like we can just call keys. So let me try that. Console.log grouped data.keys. What do we get? It's a map iterator where we have dates. Okay, cool. Map iterator, that's interesting. So it's not an array, it's a map iterator. To iterate over that, I don't know, can we use the for of syntax? Maybe, let me try it. Will this work? In. I don't know, this iterator stuff is kind of new to me. Iterators and generators. The for of loop, yeah, it should be for of, right? Yeah, the mighty for of. For, oh, I forgot the var, or the let rather. Let me try let key of group data.keys. All right, see, there we go. Boom. Okay. This is a good step to get to. Now, what we want to do is build up a row object and then push that onto transform data. And what we want to do for each of these rows is make it look like one of these rows from this stacked area chart example, because we're eventually going to want to create something just like this. It has a date property, and then it has keys for each of the things that we want to stack by. Let's start by adding the date property, So instead of key, let me just call this date, because that's really what it is. And then I'll initialize this row with the date. And now we can just say console.log transform data to take a look at what we've got here. Does not seem to be running. Something seems to be broken. Okay, there we go. Test is back. Oh no, that was a Twilight Zone moment. So let me try console.log transformed data down here. Okay. All right, see, we've got a date field and the values are dates. Okay, so far so good. So we've got the date field. Now what we need to do next is add keys for each of the D3 repositories. And we can do that in here by saying, you know, for each of these things that are inside, actually, let me get that. I'm going to say value, which is the value for this key. It's going to be grouped data.get, I believe it is, date. So this will give us the inner map. And let's say console.log value. Yeah, see, it's maps. All of them seem to just have one key. That's surprising. I thought they would have multiple keys. Maybe I'm just looking at some of them. Because, I mean, for a given month, surely there would be commits in multiple repositories. This is kind of confusing. I'm not sure if I did this right. Let me take a step back and look at grouped data again before we get into all of this. So it's a map where the keys are dates, although we've got duplicates in here. Okay, that's what's problematic. I think this is the thing that would be solved by intern map, as a matter of fact. So what's happening is that the dates are not really working as keys in the map. So maybe what we should do, in fact, is not parse them to dates quite yet. We can parse the strings to dates later. This is so that the strings could act as keys, and then if the same string is encountered, the map internal algorithm will know that they are the same. It's somehow not picking up on the fact that dates, the same date is the same date, maybe because they're different objects. So you know what? I'll just not parse the date quite yet. I'll just copy paste that line, keep this around for later, and then I'll just use this substring. Now let's see what happens. Okay, look at that. There's only 75 entries. That looks better. That looks more correct. Okay, this is great. So for each month, we've now actually aggregated by month, so there's not duplicates anymore. Okay, fantastic. So now, in this logic here, yeah, dates won't equal, says Robert. And by the way, there was a very, very recent change to D3, adopt intern map, that addresses this very exact problem that we're facing. That was only 20 days ago. Yeah, it groups the specified iterable of values into an intern map. And an intern map, this is probably actually worth discussing just a little bit. They extend the native JavaScript map and set, allowing dates and other non-primitive keys by bypassing the same value 0 algorithm, which is the same as the... Oh, I thought it was actually equals equals equals, but it's not. It's something a little different. Anyway, there's a lot of details there, but the upshot is it doesn't work with dates unless we upgrade this package. Yeah, this was published as D3 Array version 2.11.0. So that actually should be available through Unpackage. So let's, I don't know, I'm torn what to do here. Deal with the old way or try the new way. I wonder if D3 itself, the top level of package, was published recently. Yeah, 6.5.0, 17 days ago. But I wonder, did it upgrade D3 Array? I think so. So let me try that actually. It's 6.5.0, 17 days ago. Let me see if this is going to work. Yeah, see, the dependencies is set to an older version, but if I just upgrade that, whoops, upgrade that to 6.5.0, and then if I bring back the date parsing, let's see what happens now. Oh my gosh, it worked. Look at that. Oh, I'm glad I went down that little rabbit hole. Thanks for bearing with me. Totally worth it. So now you know about intern map and why it's useful. Because otherwise you couldn't use dates as keys. But now you can. Look at that. It's working with actual dates as keys because I brought back the parse date. Okay, this is actually what I want to be doing. It just feels better to be dealing with dates from the get-go. Now, what we can do is get back to our original task of building up this row object. So let's again take a look at what we need to get to. We need to get to a row object that has a date property, which we have now, and then it has keys for, in our case, the various D3 repositories, and the values for those keys are going to be, in our case, the count of commits, or the length of the commit array. So the way that we can do this is that we can use this value, which is, again, a map. Let's just inspect for a moment this value. This is what I would have expected to see. Yeah, multiple keys. So what we want is a key on the row object for each of these keys on the map. So we can again use the for_of construct to iterate through. And this is going to be let repo of value.keys. This will iterate over each of the repositories. And then in here, we can take a look at which repo it is, and then value.get repo should give us the array of commits for each of these repos. And it does. And what we're most interested in is the length of this array. So we can say .length to essentially use the count aggregation operator, if you were to think of it in terms of SQL or whatever. So this gives us the number of commits. And now we're in position to add these keys to the row. So row at the key repo can be value.get repo.length. And I think this should do the trick. Let's take a look at our transformed data after doing all this. We got 75 entries, one for each month. Okay, looking good. And then we've got keys for each of the repos. But it's not actually for each of the repos. I mean, some of them are missing. I'm not sure if that's okay or not in terms of how D3 area works. And we may not have data for each and every month as well. And that's another thing where I'm not sure if that's okay or not. See, here's one for August 2015, and then the next one is for October 2015. So we don't have any entry here for September 2015. So we may need to go through and backfill zeros. But I'm not sure. Maybe it'll just work with D3 area. But so I think I'll try it with D3 area, and if it breaks, I think the solution would be to backfill each and every month and the combinations of each and every repo with zeros. Even though that's not directly in the data, we may need to do that. But I'll try without it as a first pass. So let's again study this ISC licensed stacked area chart example in Observable. I want to know how it works. So it uses d3.stack .keys data.columns.slice1, which is all of these columns without the date. So we need to come up with somehow the list of all repos and then use that to pass it into stack.keys. Yeah, the stack transformation is the first step that we need before we start getting into the rendering logic. So let's try to make that happen. And we could even do it right here. I'll call it stacked data. Stack. And I just pasted that from the example. We need to import stack from D3. And then for the keys, we need to give the repos. So I'll imagine that there's a variable called repos, and then I'll fill it in. And the example code uses data, but what we need to use is actually transformed data. Because that's the data that has the row structure that we need that matches the example. Okay, so let's figure out what repos should be. Repos, we are grouping by date and repo, but what we really want to do is just get the listing of all the unique repositories. We could do that a number of ways. I mean, we could use an ordinal scale. We could use a JavaScript set, JavaScript map. Or we could do something very similar to what we're doing here. Just do another grouping that just groups by repo and not date. And I'll call this repo grouped data. It may not be the most efficient way of doing it, but it's the least cognitive overhead because we already have code like that. So the surface area of the APIs we're using here is minimized, which makes the code, easier to read later. So let me just console.log repo grouped data and see what we see. It's a map. It's a map where the keys are the repos and the values are the array of commits for each of those repos. And now that I think of it, this would be kind of cool to do as a bar chart. You know what I mean? Which D3 repositories have the most commits? That would be kind of interesting. But I digress. So we can get the list of repos by just calling .keys on this. Repo grouped data got .keys. And then we get a map iterator. But I think that will work. It's not an array, but let's just see if that works. I think it will work because D3 has recently been upgraded to work with iterators in most of the parts of the API that used to just accept arrays. So now I can just assign repos to be repo grouped data.keys. And now this stack invocation should work. And let's take a look. Just make some space. Let's take a look at stacked data by console.logging it. Console.log stacked data gives us an array of arrays. Okay, that's cool. It didn't break completely. I do not fully understand this data structure. Oh, but we do have some not a numbers. Yeah, that's going to be a problem for sure. For sure. So I think what we really need to do here is make sure that we have all of the repositories represented on all of the rows. Oh yeah, somebody said keys.toArray. That could work. But I think the D3 API does accept iterables, so it's not required. So the main problem is this not a number. And I think it's coming from the fact that not all rows have all repositories represented. What we can do is, to address that, instead of iterating over the keys that are present for just that particular month, meaning the repositories that had commits for that particular month, we can iterate here over all repositories. Because we have that now, repos. So let repo of repos. And then now, sometimes this will come up empty. So what we can do is we can say commits equals value.getRepo, and commits may very well be null or undefined because not all months have commits for all repos. So what we can do here is say set the value to be commits. Like, are there commits? If there are, then we can just say commits.length. Otherwise, if there are no commits for this repository in that one particular month, we should just use the value 0 to represent the fact that there were 0 commits that month. So now we have filled in all the values for all repositories, for all months for which we have data. But I think something has gone terribly wrong because we're getting empty array for stacked data. Let me check out what these row objects look like. Console.log row. It's not working? Like it's just not working. So maybe this let of doesn't work for, well, I don't know. Maybe is that not working? In this inner loop, is it even working, like going over these repos? Let's check. It does seem to be. Did I get the logic wrong for commits? Let's see, what are these commits? Okay, a lot of it's undefined, but that's okay. So I want to see the combination of repo and commits. So let me just console.log repo and commits. We should be getting a lot of these, but what's happening here is, take a look at that. It's just working for the first one, and then the subsequent ones, it's not working? And it's strange because it seems to just be going over the repositories once, but it should be going over all of the repositories for each month. So I don't know, it's a Twilight Zone moment here. Let me just comment out this code and make sure that we are going over all of the dates that we should be going over. Yeah, we are. We are. Okay. We got a date for each month. And then the value is for each of those months different. Yeah, okay. It's still coming up empty. Let me console.log transformed data. See, it's only working for the first one. I have no idea why. Why is it just working for the first one and not the other ones? This is so strange. To be honest, I'm kind of new to this for of construct, so maybe there's something weird going on with that, with the control flow. I don't know. Let me try repos.forEach, my beloved functional programming way of doing it. Let's see if that works. Oh, repos.forEach is not a function because it's not an array. It's an iterable. Oh, it's an iterable, not an array. Hey, so whoever that was that suggested earlier. Oh, now you're saying for x in array. Metal guitar covers. Thank you. Sure, I'll try that. Yeah, because the iterable, I think you can iterate over it once, and then it's like spent. It's done. So let's try for in. That also didn't work. All right, so I think what I would like to do is try array.from. So we're not dealing with any of this iterable stuff that's confusing. What? Now it looks totally different. We've got indices. Yeah, so that's what the let in, the for in actually iterates over the indices of the array, which is not what we want. So, but now let's try for of over an array. And so we've got it there for the first one. My question is for the other ones, is it there? Yes, it is. Yes, it is. Okay, done. We did that step. Got it. Okay, so we learned something about iterables. You can only iterate over them once. But if you use array.from or .toArray, you have an array that you can iterate over multiple times, not just once, using for of. Okay, cool. Good stuff, good stuff. Okay, so now we pretty much have the data structure that we need to pass into d3.stack. The one thing that kind of bugs me is that we don't necessarily have rows for each and every month, but let's just make the visualization and see how that plays out. It might be just fine. So now we can invoke this stack and then console.log stacked data. And this looks better. We don't have any not a numbers anymore. Cool. All right. I think we're done with the data transformation stuff. Now we can get on with the visualization of it. Again, I'm going to consult this observable thing, which is straightforward, relatively straightforward D3 code where it's just appending a path for each element of series. And how is series defined? Series is defined as, well, this is data. What about series? Okay, it's stacked data. So what is series here, I'm referring to as stacked data. And we're going to need this area generator. And we're going to need these scales, pretty much the same thing. It's a max of maxes. I'm just sort of surveying what's here. But yeah, let's build this up sort of from first principles. There's a bunch of logic here that is sort of cluttering up this file. So I think what I'll do is just before we move on, I'll make a new file called transform data.js, and then export a constant transform data equals data in, and then I'm just going to drop all that transformation logic into here to split it out from our main module. So I'll cut that code and then paste it over here into transform data, and then return stacked data. And then to use this in index.js, we can import it. Import transform data from /transform data. And then here we can say const stacked data equals transform data data. And it should be doing all the same stuff that it was doing before. Oh, parse date is not defined. Sure, yeah, we got to import that stuff in that other module now. We don't need JSON, but we do need all this other stuff. And then we also need parse date. I'm going to move this to that other module. Parse date. Okay, now it's working. Great, so now we've got a simple index.js, and now we can, I think I'll make another function called render stacked data. And now we can say render is a function of stacked data, and this is where we can do all of our fancy D3 stuff. So we're going to need an X scale and a Y scale. I noticed there's some stuff in the chat. Where is this recent viz? Let me just show you. If you go to my profile page and then sort by most recent, should be here. And I'll drop it in the chat as well. All right, so now that we've got this stacked data, we are in position to render it with D3, and we're going to need an X scale and a Y scale. I'm going to make this I think I'll start by making it like a pretty traditional stacked area chart. And so we're going to need an X scale and a Y scale. The X scale is going to be time. So let's start with X scale. It's going to be a I'm just realizing we don't need these imports. The X scale is going to be a time scale. I believe we can use scale time for this, which we can import from D3. And then we got to set the domain and the range. The range is going to go from 0 to inner width, and inner width, I'm going to use the margin convention here. So this is sort of a bunch of code that I sort of just know how it's going to all work out. So width minus margin dot left minus margin dot right. And we can define our margin to be an object that has top. I'll start it all off at 20. Right, 20. Bottom, 20, 20. And we're going to need inner height as well. So let me just say inner height is going to be height minus margin dot top minus margin dot bottom. And width and height, I like to just derive that from the running program. So we can use window dot inner height, or sorry, this is width, inner width. And then we can say height is window dot inner height. So now let's think about the domain of the X scale. It's going to take as input, well, you know, it would be useful to have the data before we stack it, actually. So why don't I just move that or you know what we can do is just return stacked data as well as transformed data. Or just data, because what I'm thinking is we just really want to iterate over all the data and figure out what the min and max date are. So I think I'll return data and stacked data. So over in here, we can just pass the output of transformed data into render. And then in here we can destructure that to data and stacked data. And so for the domain, we can say it's the extent, which gives us the min and the max, over the data along the X value. And this is just something that I like to use so that the code is general. Const X value is, this is going to return the date. So what this should do is figure out the min and max date. So let's figure out, let's just see if it worked. We can say xscale.domain. And if you invoke it like that without any arguments, it should return the value that was set. Okay, it's saying extent is not defined. That's okay. Extent, we have to import from D3. Okay, that seems to have worked. See, it goes from 2013 to 2021. Okay, great. Now let's just take a look at the range, make sure that's okay. 0 to 920. That looks good. That looks good because I know the width is 960 and then the margin left is 20, so 960 minus 40 is 920. Okay. Great, great, great. And now let's take a look at the Y scale. This is going to be a linear scale. And this is where I'm going to consult with the example, because this is where some funky stuff goes on regarding figuring out the max. See, it's a max of maxes. And I'm pretty sure this is the logic that we need to use as well. So I'm just going to copy paste that logic. And that's going to be used to set the domain. So we can say the domain is going to go from 0 to this max of maxes. And instead of series, we're calling the same thing stacked data. And instead of using d3.max, I'm just going to use max, which we can import from d3 with this ES6 import syntax. Yeah, and this just works with the structure that's output from D3 stack. I believe the value at index 1 is the max of that particular slice. So we're taking the maximum over all the various slices. So let's take a look and see if this is working. Okay, we need to import scale linear from D3. And now we can take a look at the domain to see if it worked. Console.log yscale.domain. Okay, that looks probably like it's correct. 778 would, I guess, be the max number of commits that we would see for all the repos combined, which is what the stacking does, for a particular month. So that's kind of interesting information right there. For a particular month, meaning the busiest month of D3 saw 778 commits in that 1 month. That's pretty impressive. Okay, now let's consider the range. The range of the y-scale is going to go from 0 to inner height, but actually, since y is flipped, the y-coordinate is flipped in computer graphics, it's going to go from inner height to 0. And I'm just using prettier here to auto-format the code. So let's just take a look at the range, see if it worked out right. Okay, that looks decent. Okay, now we can construct a D3 area generator. The area generator is d3.area, but I'm just going to use area and import that from D3. And again, we can refer to the example. The area just looks like this. It defines x, y0, and y1. We can just use all these wholesale because our data adheres to the same structure, meaning there's a field called date. And d.data is created by the D3 stack function. And so is this array of 2 values. So we can just use this. I'll just copy paste that wholesale. Area.x and y, y1. And then we can get into creating the SVG stuff, which again can look quite similar to this example, except this this seems to be some D3, some observable specific stuff, because it's returning the SVG node. But in vanilla JavaScript, we can just append an SVG element. So I'll say const SVG equals I'm going to just append it to the body. So we can say d3.select body dot append svg. And select, we're going to have to import from D3. So now we've got this SVG. The first thing you always need to do with SVG is set the width and the height, because the default is some weird set of numbers. So set the width, WID. Set the width attribute to width, the variable that we have from earlier, which is window.innerWidth, and we can do the same for height. Height is height. So now if we run this program and inspect it, we can see that indeed, oh, we should have an SVG element there, but we don't. Don't know why. Oh, something is wrong. d3.area.x is not a function. Oh, pretty sure we need to invoke that as a function, because this is the area constructor that we imported from D3. So we have to invoke it as a function to create a new instance of this area generator, and then use the method chaining. Yeah, that's what it was. So now if we inspect the element, we have an SVG there. But we get these unfortunate scroll bars, which is something that is a recurring problem. We can address it with some CSS. On the body, we can say margin is 0. But we still get a vertical scroll bar. So we can say, I researched this one time, by the way. It's something very weird about cascading margins or something. So I think this is the best way to deal with it. Overflow to be hidden. That will just get rid of our scroll bars. Okay, that looks good. No more scroll bars. All right, now that we've got this SVG, we can implement the margin convention by appending a group element and then translating it by the left and the top margin. So we append a group element. We set the transform attribute to be a string template literal that says translate, and I'm going to put these placeholders here. We want to translate in the x direction by margin.left, and in the y direction by margin.top. I'll use prettier. Okay, now this should give us a group element, which I'll refer to as G. This is a D3 selection of this newly created group element. And now we can say G dot, and this is where we go in and create a bunch of path elements. So we can use the D3 data join pattern and say G.select all path dot data, and we can pass in stacked data here. Dot enter dot append path, and I'm coding this in such a way that it's only going to run once. If we wanted to run this multiple times, we'd need to use the general update pattern, but that could be a later refactoring as needed. So once we append these path elements, we can set the D attribute of each path, which is an SVG thing. It's a domain-specific language that can be used to define the coordinates of the path. For that, we can just invoke this area generator with the data, or the data at a certain index. I don't quite remember. I'm going to consult the example. So the ATTRD is just set to area, which is kind of interesting. What this ends up being is it's going to be invoked for each element of the series, which is what we want. Okay, so this should actually work. Does it run? Do we get some paths? We do, but they're all empty. I'm not sure what's going on. Oh, that's probably what's going on. X is not defined. Where is X being used? Oh, yeah, well, okay, fine. In the observable example, X was the X scale, but in our code it's specifically X scale. So that's what the problem is. X scale and Y scale. Just a naming convention. All right, look at that. Got something to show up. As night falls, I have to adjust my green screen settings here. Whoops. Apologies. Oh no. Oh, forget it. All right, we've got something show up. This is pretty cool. I kind of like these broken states. So I'm going to actually fork this. I'm just going to leave this the way it is because it's kind of cool. So what is going on here? No idea, honestly. Yeah, I don't know. One thing we could do is try making the different paths different colors. So let me try that. Set the fill to be just random colors. I'm just going to create some random colors here. Math.random times 255. This is an old trick I like to use just to make random colors. Okay, that's kind of cool too, isn't it? It looks like there's some problem with like the way that it wraps around. Oh, hey, Quincy Larson. Nice. Looks like a makeshift skateboard ramp. Ha! Right on. Right on. Yeah, this is kind of cool too. I'm going to fork from here to keep this broken state around as a artifact of history here. And every time you refresh, by the way, it's different colors. It's kind of cool. Let's see if I run it again. Boom, different colors. A total D3 broken made art situation. But why would this be? I mean, honestly, I don't know. Someone's calling me. Oh no! Oh, I have to go. I have to take that. Well, this is fun. Made it this far. So I will stream another time. Thanks everyone for tuning in. Hopefully I'll stream again same time next week, and we can wrap this up and make a really cool stream graph. But this has been a fun experience, a fun experiment in knowing. One thing is like, I think I can get more done than I actually can in 90 minutes, so it's a good learning experience. But anyway, thanks all for joining. I will do this again. I'll let you know. Take care. Bye.